Question 1. Because of lanthanoid contraction, which of the following pair of elements have nearly same atomic radii? Numbers in the parenthesis are atomic numbers. We're given over here. We're given 4 options over here. Due to lanthanoid contraction, zirconium and hafnium possess similar properties. This is due to similar number of valency electrons, atomic radii, and the almost same size of these elements. Thus, they are called as chemical twins. Therefore, option C is a correct answer. Question 2. The correct statement is, we have given 4 options over here. The earlier members of lanthanoid series resemble calcium in their chemical properties. B. The extent of actinoid contraction is almost the same as lanthanoid contraction. C. In general, lanthanoid and actinoids do not show variable oxidation states. D. Cerium aqueous solution is not known. If we see option B, the extent of actinoid contraction is greater than lanthanoid contraction. This is due to lesser shielding of 5f electrons in the actinoids as compared to the shielding of 4f electrons in lanthanoids. And option C, in general, both lanthanoids and actinoids show variable oxidation states. And in option D, cerium exhibits +4 oxidation state. Therefore, cerium is a good oxidizing agent. Therefore, we see option A, that the early members of lanthanoid series resemble the calcium in the chemical properties, is a correct answer. Question 3. Which of the following is a transition element as per the ground state electronic configuration? We're given 4 options over here. Since zinc, cadmium and mercury have a completely filled n-1 d orbitals in their ground state as well as in the form of ions, they are excluded from transition series. Hence, among the given option, only Au, that is gold, is a transition element. Therefore, option A is a correct answer. Which of the following oxide has a maximum basicity? They are given 4 options over here. The oxides of lanthanoids, that is Ln2O3, react with water to form corresponding hydroxide, that is LnOH3, which are basic in nature. The basicity of this hydroxide decreases from lanthanoid hydroxide to LuOH03. Therefore, among the given option, La2O3 has a maximum basicity. Therefore, option A is the correct answer. Question 5. On heating potassium permanganate, one of the following compound is not obtained. We're given 4 options over here. When heated to 743 Kelvin, potassium permanganate decomposed to give K2M4 MnO2 and O2. Therefore, we see a reaction, that is 2KMnO4 when heated, that is potassium permanganate, it gives us 2KMnO4 plus MnO2 plus O2, that is potassium manganate, manganese dioxide and oxygen. Therefore, option B is a compound which is not obtained. Therefore, option B is a correct answer. Question 6. Noble gases are group of elements which exhibit very, we're given 4 options over here. A. High vaporization enthalpy. B. Low chemical activity. C. Minimum electronegativity. D. Much paramagnetic properties. Zero group elements show less chemical activity because elements of this group have stable electronic configuration. Therefore, we see option B, that is low chemical activity, as a correct answer. Question 7. Which of the following will react with fluorine? We're giving four options over here. Very few compounds of krypton are known, that is, therefore krypton difluoride is studied in detail. True compounds of argon, neon, and helium are not known till date. Therefore, option B, that is krypton, is the correct answer. Question 8. Acidity of diprotic acid in aqueous solution increases in the order. We give four options over here. On moving down the group 16, bond length increases from H to S to H to Te and MH. Bond dissociation enthalpy decreases. Thus, the acidity of diprotic acids in aqueous solution increases in order H2S, H2SE, H22E, which is we see option, our answer matches with option A. Therefore, option A is the correct answer. Question 9. Which of the following halogen does not exhibit positive oxidation state in its compound? We give four options over here. Most electronegative fluorine shows only -1 oxidation state. Chlorine, bromine, and iodine show -1, +1, and +3. That is chlorine, this is bromine, and this is iodine. Sometime +5 and +7 oxidation states. Chlorine and bromine also exhibit +4 and +6 oxidation states. Therefore, we see fluorine, that is option D, is the correct answer. Question 10. Among chlorine, bromine, and iodine, the correct order of the being oxidized to dihalogen is. We give four options over here. Halogens are strong oxidizing agents. Oxidizing power undergoing self-reduction of halogen decrease from fluorine to iodine. Hence, the ability of halogen to undergo oxidation will increase from fluorine to iodine. That is, the order of being oxidized to dihalogen will be hence the correct order is iodine, bromine, and chlorine. Therefore, we see option C is the correct answer. Question 11. Least volatile hydrogen halide is. We give four options over here. Hydrofluoride has a relatively high melting and boiling points due to presence of intermolecular hydrogen bonds, which leads to association of hydrofluoride molecules. Hence, at room temperature, hydrofluoride is a liquid, while HCl, HI, and hydrobromide are gases. Thus, hydrofluoride is the least volatile hydrogen halide. Therefore, option A is the correct answer. Question 12. Among the following oxoacids, the correct decreasing order of acid strength is. We give four options over here. The increasing order of charge delocalization in the anions of oxoacids of chlorine is ClO, then ClO2, ClO3, then ClO4. With increase in charge delocalization, the ability of the ion increases and the basicity of the anion decreases. Thus, ClO- is the strongest base and ClO4 is the weakest base. A weak base has a strong conjugate acid and vice versa. Hence, HClO, that is conjugate acid of ClO-, is the weakest acid. And HClO4, conjugate base of ClO4, is the strongest acid. Hence, the correct decreasing order of acid strength is HClO4, HClO3, 2Cl. Therefore, we see option C matches the correct answer. Therefore, option C is the correct answer. Question 13. In which of the following arrangements the sequence is not strictly according to the property written against it? We give 4 options over here. On moving down the group, the atomic size increases. Due to this, electron density, the electron donor capacity, and the basic strength decreases. Ammonia is distinctly basic. Phosphine is a very weak base. Arsine, stibine, and bismuthine do not show any basic property. Therefore, we see option B, that is ammonia, phosphine, arsine, stibnine increasing basic strength as a correct answer. Question 14. Electronic configuration of only one p block element is exceptional. One molecule of that element consists of how many atoms of it? We give 4 options over here. The valency shell electronic configuration of p block elements is S2 and P1 minus 1, 1 to 6. Except helium, which has 1 s raised to 2 configuration. Helium contains completed duplet, and hence one molecule of helium consists of only one atom, that is, it is a monoatomic element. Therefore, option A, that is 1, is the correct answer. Question 15. What is a smoke screen? We given 4 options over here. When phosphine comes in contact with air, it forms a ring of white smoke of phosphorus pentoxide, which act as smoke screen. Therefore, option C, that is phosphorus pentoxide, is a correct answer. Question 16. Alkaline earth metal compounds are less soluble in water than the corresponding alkali metal compound because the former have. We give 4 options over here. Higher covalent character according to Furjan rules lower the size of the cation, that is alkaline earth metals cations are smaller in size than alkali metal cations. Higher is the covalency. Therefore, lower the size of the cation, higher is the covalency. Therefore, option C is the correct answer, that is higher covalent character. Question 17. An atom with atomic number 20 is the most likely to combine chemically with atom whose atomic number is. We give 4 options. Z is equal to 16. The atom with Z is equal to 20 has 2 electrons more than argon gas configuration and thus has a strong tendency to lose these electrons. Therefore, it will combine readily with that element which can accept these electrons, that is element with 16. Therefore, option C is the correct answer. Question 18. The decreasing order of the second ionization enthalpy of potassium, calcium, and barium is ionization enthalpy of potassium is highest since the second electron is to be lost from the inert gas core, that is argon. Further, because of the larger size of barium as compared to calcium, its ionization enthalpy is lower than that of calcium. Therefore, potassium is greater than calcium, where calcium is greater than barium, which is we see our option A is the correct answer. Question 19. The atom with atomic number 12 will most likely combine chemically with the atom whose atomic number is. We give 4 options. The atom with 12 can lose 2 electrons. Therefore, the atom which can accept these 2 electrons must have 16. Therefore, option D is the correct answer. Question 20. A metal M readily forms water soluble sulfate, that is MS4, water insoluble hydroxide, and oxide, which becomes inert on heating. The hydroxide is soluble in sodium hydroxide. The M is among four options, that is we see A, that is beryllium, which forms water soluble with sulfate and water insoluble with hydroxide and oxide. Beryllium hydroxide is soluble in sodium hydroxide, giving sodium berylate, that is Na2PO2. Therefore, option A, B, that is beryllium, is the correct answer. Question 21. Identify the correct statement. We're given four options over here. A. Elemental sodium can be prepared and isolated by electrolyzing an aqueous solution of sodium chloride. B. Elemental sodium is a strong oxidizing agent. C. Elemental sodium is insoluble in ammonia. D. Elemental sodium is easily oxidized. Because of its low ionization energy, elemental sodium loses its valency s electron easily and undergoes oxidation. Therefore, option D, that is elemental sodium is easily oxidized, is the correct answer. Question 22. The stability of the following alkali metal chlorides follows the order. We give four options over here. Stability of a compound depends upon its enthalpy of formation, delta H. The more negative value of delta H shows more stability of a compound. Thus, potassium chloride is more stable and lithium chloride is least stable. If we see that delta HF for lithium chloride is equal to minus 408.8 kg per mole. Same for sodium chloride, 412.5 per mole. And for cesium chloride, per mole, and potassium chloride is equal to 436 kg per mole. Therefore, we see KCl is more stable than the lithium chloride. Therefore, option D is the correct answer. Question 23. Pick out the statement S which is are not true about the diagonal relationship of lithium and magnesium. We give four options over here. Polarizing power of lithium and magnesium are almost same. B. Like lithium, magnesium decomposes water very fast. C. Lithium chloride and magnesium chloride are deliquescent. D. Like lithium, magnesium readily reacts with liquid bromine at ordinary temperature. We're given four options over here. Magnesium decomposes water very slowly and also does not react with liquid bromine readily at a room temperature. Both this property are contrary at lithium. That is to lithium. That both these properties are contrary to lithium. Therefore, we see that is B, like lithium, magnesium decomposes water very fast, and D, like lithium, magnesium readily reacts with the liquid bromine at ordinary temperature. Therefore, option D, B, and D are both the correct answer, which is not true about the diagonal relationship of lithium and magnesium. Question 24. Which one is the highest melting halide? We give four options over here. We see lithium chloride and lithium bromide are covalent and hence their melting point are low. Amongst sodium chloride and sodium iodide. Sodium chloride has a higher ionic character because chlorine ion is smaller than iodine ion and hence has a higher lattice energy than sodium iodide. Therefore, sodium chloride has a highest melting point. Therefore, option A is the correct answer. Question 25. The carbonate that will not decompose on heating is, we give 4 options. All alkali metal carbonates except lithium carbonate are highly stable to heat as compared to other metal carbonates. Therefore, we see that is lithium carbonate, option D, is the correct answer, which will not decompose on heating. Question 26. Which of the following is used as barium meal for getting the X-ray spectrum of the human digestive system? We give 4 options over here. Barium sulfate, if we see, is both insoluble in water and opaque to X-ray, and hence is used to get the X-ray spectrum of the digestive system. Therefore, option A, that is barium sulfate, is a correct answer. Question 27. The chloride of an element A gives a neutral solution in water in the periodic table. The element A belongs to, we give 4 options over here. The hydroxide of first group are strong bases and HCl a strong acid. Therefore, the chlorides of the first group elements are salts of strong acid and strong base. As such, they do not undergo hydrolysis, thereby yielding neutral solution. Therefore, we see option A, that is group 1, is the correct answer. Question 28. The electronic configuration of two neutral elements A and B are, we have given over here. Which of the following represent the structure of the compound formed by them? We give 4 options over here. A loses 2 electrons to form A2 plus, while 2 atoms of B lose 1 electron each to form 2B minus. Therefore, the formula of the compound is 2 plus and B minus of 2. Therefore, we see our answer matches with option C. Therefore, option C is the correct answer. Question 29. The charge or size ratio of cation determines its polarizing power. Which one of the following sequence represents the increasing order of the polarizing power of cationic species? That is potassium, calcium, magnesium, and beryllium. We are given 4 options over here. The increasing order of the polarizing power, charge, or a size ratio is K plus, calcium, then magnesium, then beryllium. Therefore, we see option D is the correct answer. Question 30. Compare with the alkaline earth metals, the alkali metals exhibit. We're giving 4 options over here. A. Smaller ionic radii, B. Highest boiling point, C. Greater hardness, and D. Lower ionization enthalpies. Because of the larger size and smaller nuclear charge, alkali metals have low ionization enthalpy relative to alkaline earth metals. Therefore, option D, that is lower ionization enthalpy, is a correct answer.